Greetings, Spartan fans. Today we are going to look at half-angle formulas, and as always, you will need your identity sheet. I'm going to look at some solving and some evaluating. So let's start with an evaluation. Let's look at the cosine of 2 times the inverse tangent of -4/3. So this actually isn't a half angle formula. This is a double angle formula, but no biggie. This is the same thing as saying the cosine of 2 theta, where theta is represented by the inverse tangent of -4/3. Those are 4s. Inverse tangent of -4/3 is just some angle. So if this is some angle theta, take 2 times that angle, and that angle comes from the inverse tangent. So let's draw a picture. Tangent is negative in quadrants 2 and 4, but because we are talking about inverse, our theta is in quadrant 4. Tangent, -4/3. I love it. It's a Pythagorean triple. Done. It's all you need. Boom, you just finished this. So now the cosine of 2 theta, you can write it several ways. It doesn't matter which one you choose. I'm going to choose 2 cosine squared minus 1. This comes from my identity sheet. Okay, so this is 2. The cosine is 3/5 squared minus 1. Let's see. 18/25 minus 1, I believe, is -7/25. You would have gotten the same answer had you used a different substitution for cosine 2 theta. Doesn't matter. Same answer either way. Let's do a half angle. Okay, let's do the cosine squared of 1/2 times the inverse sine of 3/5. I love it. 3, 4, 5. So this is some angle. This is the same thing as saying the cosine squared of 1/2 theta, which is the same thing as theta over 2, where theta is represented by the inverse sine of 3/5. Okay, so it's positive 3/5. Love it. Quadrant 1. So now I have found my theta. Found my theta. So now I'm going to do a half angle formula for the off of my identity sheet. So this is the same thing as the cosine of theta over 2 squared. Okay, so you'll notice that it says on your identity sheet, plus or minus. This comes based off of which quadrant is your theta in, theta, alpha, whatever. So plus or minus, my angle theta is in quadrant 1. So I'm going to look at the positive root. So it is the positive root of, and in this case, it wouldn't matter because you're squaring it. This came from my identity sheet. The plus came from the fact that theta is in quadrant 1, and therefore all of your trig functions are positive, hence where that positive is. At the same time, because you're squaring it, it's positive anyway. So if you messed this up and wrote it as negative, which would be incorrect, but your careless mistake would be resolved by the fact that it's squared. So this is the same exact thing as 1 plus the cosine of theta over 2. And now we just do some evaluating. So let's see, the cosine is 4/5 plus 1 is 9/5 over 2, which is 9/10. These types of problems are purely identifying, using your identity sheet to get the substitutions, draw your triangles, and then plug in. Okay, let's look at some solving. About the cosine of 2 theta is equal to 2 minus 2 sine squared theta. And we are going to solve from 0 to 2 pi. Okay, so I have to do a substitution. Whenever you're doing any kind of solving, you have to get rid of the 2 theta, or if it's 1/2 theta, theta over 2. You have to do a substitution to get rid of that. You could also substitute for sine squared. I'm not going to go down that route yet. So for cosine of 2 theta, you have 3 options. Cosine squared minus sine squared, 1 minus 2 sine squared, 2 cosine squared minus 1. Well, the right-hand side of my equation involves sine squared. So I'm going to choose the substitution that involves only sine squared. So that's 1 minus 2 sine squared. And now I have only sines. You could have gotten the same answer using the other substitutions, but this one I think you can see now is nicer because I have all of the same function. Well, add 2 sine squared to both sides and you get 0. No solution. Gotta love it. Done. All right, so of course we're going to look at another one that's not quite so fast. Okay, let's look at again solving from 0 to 2 pi. Let's look at the cosine of 2 theta plus the cosine of 4 theta equals 0. Okay, so a little note here. This does not equal the cosine of 6 theta. Very common mistake. You cannot add the arguments, I guess you want to call them. Cool. I have a cosine of 2 theta. The cosine of 2 theta I can pull off of my identity sheet. I'm going to do that in a minute. So the cosine of 4 theta is the same thing as the cosine of 2 times 2 theta. Okay. And I'm just going to rewrite the cosine of 2 theta. So I'm going to rewrite it as the cosine of 2 alpha, where alpha is 2 theta. Lots of 2's. So 2, and if I make this alpha, which substitution should we use? I don't think it matters, but when I'm done substituting here, I'm going to use that same substitution here. So let's just stick with cosines. I don't know why, that's just what I feel like doing. So I'm going to say that the cosine of 2 alpha is 2 cosine squared minus 1. So the cosine of 2 alpha You can use any of the ones that you want. I'm going to say 2 cosine squared theta. Let's use alpha. That's supposed to be an alpha. Okay. But alpha is really 2 theta. So this becomes the cosine of 2 cosine squared 2 theta minus 1. So the cosine of 2 alpha is 2 cosine squared alpha minus 1, but alpha is 2 theta, so I substituted in 2 theta. I'm going to use the same substitution for the cosine squared. I might change my mind, but so right here. Okay, so now I'm going to do another substitution. So that would be cosine squared 2 alpha. So this becomes 2 cosine squared theta minus 1 squared minus 1. And I have forgotten the 2 because it's 2 cosine squared alpha. So there needs to be another 2 in there. One of these days I will learn to use erasable pens. So this should be two parentheses 2 cosine squared alpha. There we go. Okay. All right. A lot of distributing, a lot of combining like terms. So this is 2 4 cosine to the 4th alpha minus 4 cosine squared alpha plus 1 minus 1. I distributed out the 2 cosine squared and got here. Okay, let's just do some combining of like terms. I would imagine I'll be able to factor this, I hope. Oops, ay. No parentheses there. I need the minus 1. I'm just distributing, combining like terms, etc. So this is going to be 8 cosine to the 4th alpha to minus 6 cosine squared alpha. And this is going to be negative 1 plus 2 minus 2. No. Negative 1 plus 2 is 1, minus 1 is 0. The easiest part of the whole problem, negative 1 plus 2 minus 1, and I can't seem to get that right. All right, let's factor, because I was hoping, I'm thinking to myself, wow, all these 4th powers, this is going to be tough. But now I'm going to take out the common factor, which in this case is 2 cosine squared times 4 cosine squared minus 3. Zero product property. So 2 cosine squared theta is 0. The cosine of theta is 0. And the cosine of theta is 0 at x is 0, pi over 2 and 3 pi over 2. This is going to be cosine squared equals 3/4 square root. The cosine is plus or minus root 3 over 2. How about cosine root 3 over 2? That's a third degree reference. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. You can always check on your calculator. You can always check on your calculator. Go back to the original problem, blah, blah, and you should get 0. That is some double and half angle formulas. This one's a double angle formula, obviously, but practice with solving, and we'll do some proofs live in class.